The diagram shows what happens when you apply one function, g of x, after another function, f of x. The output from the first function becomes the input for the second function. When you combine two functions, as in the diagram, you form a composite function. Now here's the diagram. First consider at the top left, the domain of f are all values x, substituted as inputs into the function f. Now the function f leads to an output, or a series of outputs, the range of f. We can refer to those as f of x values, or outputs of f. If we immediately take the outputs of f and use those as inputs into a new function, g, the outputs f of x become the inputs of g. Those inputs placed into the function g become the function g for the input values f of x. We can read this as g of f of x. Take note, key concept, composition of functions. The composition of function g with function f is written as g and this symbol, almost like a degree symbol, but rather than superscript at the midline, and is defined as g of f of x equals the function g of f of x. The domain of g of f consists of the x values in the domain of f for which f of x is in the domain of g. The color coding here helps us to see two steps. We would evaluate f of x first. So for input values x, we evaluate them using the function f. That's step one. In step two, we then use f of x, the output value or values, as the input for the function g. Function composition is not commutative, since f of g of x does not always equal g of f of x. Problem 3. Composing functions. Let f of x equal x minus 5 and g of x equal x squared. What is g of f of negative 3? Well, we can use two methods. First, method 1. G of f of x equals g of f of x. In this case, that's g of x minus 5. Note x minus 5 comes from the function f of x. We're placing that into, or in the input place for the function g of x. Now g of x is its input squared. So we'll take x minus 5 and square it. Now g of f of negative 3, our given input value in this problem, will equal that same expression, but with negative 3 in place of x. So negative 3 minus 5 squared. Simplifying, that's negative 8 squared, or 64. Method 2 is slightly different. G of f of negative 3 is g of f of negative 3. So rather than using the abstract form with an x in place as a variable, we'll go right to substituting negative 3 for x. And now we evaluate f of negative 3. That will be negative 3 minus 5, still in the input position for the function g. That's g of negative 8. Now g is x squared, or input value squared, so negative 8 squared, and that's 64. Your turn. Let f of x equal x minus 5 and g of x equal x squared. What is f of g of negative 3?